Welcome to lecture 5. In lecture 5, we are going to introduce the inverse kinematic solution for robots. This means if the frame of the end effector is known, we should inversely find the values of the joint angles. For example, the forward kinematics of such a simple robotic system is known for the hand frame ZH-XH related to the base frame Z0-X0. For the given information of the forward kinematics, we need to find the values of the joint coordinates theta 1 and theta 2. So we have in the first step to find the forward kinematics. In this simple example, in the first place, we would use the algebraic solution by choosing some elements. For example, by choosing the elements 2, 1, which is sine theta 1 plus theta 2, and equating with ny, and choosing the element 1, 1, which is cosine theta 1 plus theta 2, and equated by nx. By this way, the angle theta 1, 2, or theta 1 plus theta 2 will be equal to a tan 2 ny comma nx, which means ny divided by nx, and tan 2 is used in order to indicate the right quadrant, so that the sign in the numerator and the sign in the denominator should not be cancelled in case of a negative value. Okay, the first step, we find theta 1 plus theta 2. So by using the element 1, 4, row 1, column 4, which is a2 cosine theta 1 plus theta 2 plus a1 cosine theta 1, this will be equal to px. Then from this relationship, a2 multiplied by nx plus a1 cosine theta 1 is equal to px, as nx is equal to theta 1 plus theta 2 from the previous step. From this equation, we can find that cosine theta 1 is equal to px minus a2 nx divided by a1. Simply, from 2, 4, we can get sine theta 1, and by this way we have decoupled the angle theta 1 from theta 1 plus theta 2. By having cosine theta 1 and sine theta 1, we can get theta 1 as a tan 2 sine theta 1 divided by cosine theta 1. All the numerical values are given for the parameters from the right hand side. We can calculate theta 1, and knowing from the first relation here, the relation between theta 1 plus theta 2, we can get. In case of more sophisticated robots with more than 2 degrees of freedom, we can simply use an alternative solution by decoupling the relationship between the angles by multiplying by the inverse. For example, for the same example with 2 degrees of freedom here, in order to get rid of the matrix A2, sorry, we multiply by its inverse to get A1 separately. And by this way, step after step, we have the ability to separate theta 1 from in order to find simple relationships through the elements of the matrices in the left and the right side to find theta 1 and theta 2.